Right, so my name is Gijs Stuurman. I'm a Clojure programmer from the Netherlands, where I work as a freelance programmer. And this is my first Clojure conch. The story begins in 2002, back in Zaandijk in the Netherlands, where we have the windmills in Zaanse Schans, which is an open-air windmill museum. More relevant is that in 2002 I was in my final year of high school, and I started to dabble around a bit with programming. And I found this book online, which is called Thinking in Java by Bruce Eckel, which was the first book I started programming with. Accidentally, this guy, Bruce Eckel, also wrote a book called Thinking in C++, but for some reason I chose the Java one. I guess if I chose the C++ one, I would have invented Clojure 20 years later, as we learned this morning. Then in 2003, I went to university. This was in Enschede, also in the Netherlands. It's not really famous for much, except that it has the Grols brewery, where they brew this beer. But very much I had to continue thinking in Java. Everything we did there, programming was in Java, classes were in Java, assignments in Java. Even if it's only tangibly related to programming, the assignment would be in Java. So more thinking in Java. And then in 2007, in my third year, there was or the third scheduled year, there was an elective class you could take on functional programming. And I checked it out. And that was actually quite a revelation for me. So the code you see here is from actual practical assignment I had to do. I had to drag up a CD-ROM with a backup where it was still on. But I distinctly remember that at that time this looked amazing, this code. We were building tiny programs. This is like in Amanda, so like a Haskell ML type programming language. We were building tiny programs. We could make GUIs with very few lines of code, and everything just felt very relatable, like to what we are actually doing. You have an assignment, you write some code, and you fix the assignment. It was a nice short feedback loop by compiling the program and running it. To me it was a revelation, so I was hooked on this functional programming idea. So from there on I went to explore this idea, and I found both Scheme, which you see on the left, and Clojure on the right. And for Scheme it's important that on the left you see here something called Dr. Scheme, which is the Scheme programming environment that you can download. And more importantly for this talk with Dr. Scheme, there are also a couple of examples programs, which is the Gin Rummy card game. So there were loads of example programs that came with it, but this one I liked. So for those of you who don't know the Rummy card game, I'll briefly explain. It's a card game with a regular 52 card deck. You play with two people, so against your opponent, and on each turn you have the choice to fill out your 10 card hand that you have by picking either a card from the deck, which is face down, or from the discard pile, where one card is face up. You take a card from either pile, you then have 11 cards in your hand, and then you discard a card again to end up again with 10 cards. And the goal of the game is the winner is the first one to arrive at the gin hand, which is where the 10 cards combine into a winning hand, which consists of 3 sets, or melts as they are called. So you have one of 3 cards, and then one of 4 cards. And then each set or melt has the property that it's either a straight flush or like a 3 of a kind, 4 of a kind. So in this example, I think you have a Jack to King, straight flush, 3 of a kind or 5s, and then 8 to Jack, straight flush again, which make the bottom player the winner in this hand. There are also some other rules for Gin Rummy. If you maybe already know the game, you can do knocking and other types of rules. But this game and the game I'll be implementing is only with these simple rules I just explained. Any other things do not apply. And like I said, in the Dr. Scheme environment, you also these were all examples in Scheme. So you had the code there. What actually the code does here is not important, but the code was available. You could see how they made the GUI, you could see how they made the drag and drop, and you could also see what the AI was of the opponent that they programmed. This was the part I found quite interesting. And like I said, I found these sort of at the same time for my functional programming course, jumping into functional programming. So at the same time I was also looking into Clojure. And then if you have any questions about Clojure, you can go online and people will help you. The same is still true today, although now we're no longer on IRC, or most of us, I guess not. Now we're on Slack, but still you will find helpful people to help you out if you have a question. And of course, for my regular background at university, I was mostly a Java programmer, so I knew Java. and because Clojure ran on the JVM, I thought I'd go build something. And one of the interesting classes I ran into is the java.awt.robot class. This is a class in the standard Java library that does basically two things. It can make a screenshot of your desktop or wherever it's running and just give you the information of all the pixels. And it has functions to actually move your mouse and take over the mouse, so to generate clicks, double clicks, and everything like that. So I thought I'd combine the two and actually make a robot that could play this Gin Rummy game. Like I said, I knew Java, and with Clojure you can use Java, so this is the actual Clojure code that just uses this existing Java library. And then the resulting robot looks something like this. Right here. So on the left you see the Gin Rummy game, it will be the different implementation. And on the right is the robot, which basically goes through a loop. It takes a screenshot of the entire desktop. It tries to recognize all the cards. So it sort of knows where all the cards are, but not exactly. So you can sort of see that every card recognition goes in like a two-step process. It sort of knows where it is, and then from the tiny clip of the desktop, it will try to find the edges of the card, and with that information it knows enough to actually recognize which card is which. And for each card it only needs to sample a few pixels in the top left corner to be able to distinguish which card is which. And then the robot also has the same AI as the opponent in the program here, so then it makes a decision on what to do, and then it gives the mouse instructions to actually make these moves. And this will go on until there is a winner. And one of the things that needs to happen is that your UI has sort of, you have 10 cards in your hand, but then you sort of have to, you're allowed to place them wherever you like, but there's no actual placement of putting them all in full view. So the robot is always busy to make sure that every card is actually visible, so it can see and make a decision. And this goes on until there is a winner. So like I said, the scheme code for the actual opponent was already available. So I ported that into Clojure. And here's an actual snippet from that scheme code. And if you may know, a scheme is also like a Lisp and perhaps a functional programming language. But then if you look at this scheme code, this looks more Java-ish than it does functional code. Because here, a card in this card game in the scheme code is like a class, and it's both a combination of the actual suit a card is, the rank a card is, as well as all the code you need for putting it on the screen, how big is the image, where does it go on the pane, and how do you do drag and dropping. Whereas in Clojure, we just put it in a map. Of course, this is only just the data for a single card, but this is it. This is how you represent a card in Clojure. And of course, this is a trivial example, but even the trivial example is still trivial, which is also valuable, I think. So here you see in the Clojure, a card is just a combination of its rank and its suit. And then in the Gin Rummy version, we need 10 cards per hand. So you just make a vector of it, or a collection with 10 of these cards. This is already a stark contrast, but I think a good example of what is nice about Clojure. The data is just data, and you can read this data. I wrote it down here, and I think it's fairly easy to see what this should represent compared to what this class is on the left-hand side. Then I was still in university, so then we arrived in 2010. I built this Gin Rummy robot with Clojure, and I had to do my first real programming exercise for my graduation master thesis. And because I had fun doing this Clojure thing, it actually worked. I decided to do this project in Clojure, and then I had to build a simulator that executed semantic specifications for modeling languages. But the useful thing here is that because I played around a bit and made a little toy project, I felt confident enough to actually build a project on a sort of a deadline in a couple of months with Clojure, and that worked out well. So I guess what I learned there, in particular with regards to Clojure, the Java interop is great. I could indeed use everything on the JVM, and this whole focus on data and functions, or perhaps rather values and functions, is quite nice. From then I moved to Utrecht, also in the Netherlands, If you look at this building, you might be thinking, is that a UFO on the building? It is. When I was in Utrecht, I had my first job out of university. I actually joined a company where I worked on Ruby on Rails websites. At that time, there were no Clojure jobs available in the Netherlands yet. I did manage to sneak in a little bit of Clojure by transforming a CSV importer into a Clojure program, as it was a standalone thing. So if you want to try and introduce Clojure at your job or anywhere else, find maybe a tiny piece you could replace and go from there. And then also in 2011, ClojureScript was released. Richiki did this with this quote: Clojure rocks and JavaScript reaches. Both I think are true. I already knew that Clojure rocked, and with my work I also had to do a lot of JavaScript, and this was indeed the way to reach people in the browser. So I was really intrigued by this idea. So once again I wanted to try this out. So what I did again was just get the card game, but this time make a version in the browser. So using ClojureScript, I would build the exact same version that I had in Scheme in the browser. And this, of course, also meant that I could show people this game more easily. Because there is a huge difference between telling people like, yeah, I use this little game that you can find and install in a thing. But of course, we all know it's much easier to just send somebody a link and show somebody something. And this is also actually the version you saw the robot play against moments ago. So in the deck of cards, in the ClojureScript version, there are 4 aces, as in any deck of cards, and I gave each of them their own logo. I'll go through them one by one. The first one, this is the logo for Scheme. This is of course just a tribute because that was the original game as well as the code for the opponent. Scheme is now known as Record, so if you want to look it up online, look for that. And the Ace of Spades has the Clojure logo. I now even have a sticker with the new ClojureScript logo, but at the time we didn't have it. And ClojureScript, of course, is what I made it in. And the 2 things were I had to build there. First, of course, is just the code for the opponent, but I already had made that in Clojure for the robot version. And then all the tricky bits with the DOM, the UI, the drag and drop, the mouse handling and stuff like that. And it was actually also quite nice to do in ClojureScript. Because for the first part, if you have code in Clojure already, particularly if it only handles data and functions, if you just change the file extension, you can use it as ClojureScript code. Nowadays that's even easier by just using CLJC files. And then for the more difficult things in JavaScript or JavaScript applications, this is quite handy. This is the Ace of Hearts with the Google Clojure logo. And if you may know, Google Clojure is the underpinning of the ClojureScript compiler. And it also has a huge library with everything you might need for DOM manipulation, mouse handling, keyboard handling. If you want modals that are always visible, even if they are perhaps in a corner. If somebody needs it in a web app, it's probably in this library. It's a huge library. But one thing, like I said, I used to work with Ruby on Rails and JavaScript in the form of maybe jQuery snippets or smaller snippets of JavaScript. And then if you are exposed to a Google Clojure library and the way they do JavaScript, it's completely different. Luckily, there's a solution there. Whenever you look up anything regarding Google Clojure, they always refer to this book, the definitive guide. They may have well called it the mandatory guide, because anything you might want to know, it's actually in there. And the inverse is also sort of true, that if you are interested in how anything works, you probably cannot find it anywhere else online. If you want to learn how Google Clojure works through only the API docs, maybe some guides which are available online, you'll get frustrated quite quickly. So I would advise to actually read this book. And I think the same thing is sort of true for Clojure itself. A lot of things are probably a lot different from what you're used to before, so I suggest, and I have done this too, is to read a lot of books about Clojure, because then you're actually taught something in context, and whenever something is new, you'll learn why that is different from what you may be used to. These 2 examples are not in particular, you can choose any book with Clojure in the title, I think. And I also must say that the videos for Clojure are quite nice to learn from. Then the fourth ACE is the ACE of clubs, which is apt in this case because it stands for the Amsterdam Clojure Meetup. I've been lucky to have had a very active Clojure user group nearby for many, many years. And I've been there many, many times. And this meetup is not just to learn about Clojure, to share projects you do with Clojure, ask questions, but I also, it's where I learned Emacs, because the only way you can learn is when you see somebody do something, you're like, what exactly did you do, how does that work? And from then on, I could learn Emacs myself. But it's also been quite useful actually for work. I visited the meetup lots of times, and almost all of my work has come through the meetup, through referrals and things like that. And also when I first started going there, I was still a student, but then you see people there that are working programmers, maybe further along in their career. It was also quite useful to just see what they are up to and to learn from them. So I also would recommend visiting a local meetup if there is one. So this ClojureScript version, what did it teach me? Well, one thing that Clojure can run in the browser, and it works quite nice. And I would advise using books for learning. And also ClojureScript, since then, I don't think I've had a job where I did not have to use ClojureScript, because almost everything I've built had a component that also, maybe even only internally, had some sort of web component where it was nice to have a nice dashboard or something for which you could use ClojureScript. So that's been very helpful for me. All right, then we get to 2012. Then I moved to Amsterdam, the Netherlands, which also marks the first year that I actually got to work with Clojure professionally, and I've done so since then. And what I also started doing in 2012 is to start a blog. One thing, it's nice to just keep track of what you've actually been up to, but it's also been useful for me to actually use as a bit of a motivational device to make sure I actually finish projects. Because I had a lot of things where I would just start stuff and maybe look into it like, oh, this is nice, this is interesting. But I found it quite useful or helpful to actually finish projects, to also get to like the last 20% of something. And particularly for myself, this is something I have, is where if I'm sort of interested in something and then maybe the newness wears off, then I might not finish it. But I now usually set myself a target, like, okay, at least make a blog post at the end, so make sure you actually complete this project. That's been quite helpful since then. Then in 2014, I decided to make another project. 2 years earlier, in 2012, Datomic was released. Again, I thought this was quite interesting, so let's investigate. So I again decided to make a card game version. This time, again with a ClojureScript front end, but you could play it over the internet, and then Datomic would be the database for the system. So that's basically what it looks like. Of course, you can play this time against an actual human opponent over the network, but that requires having at least one friend. You can also play against the AI over the network. This is useful during development, so that's why I put that in there. This is sort of what the architecture looks like. I'm not going to go into this version completely, but the important part is that Datomic was the database for this version. On the front end, I used the data script, which is a ClojureScript variant part of Datomic in ClojureScript. It's more of only a data structure rather than a database with Datomic principles. And what I also want to highlight is that I do use Datomic and DataScript here, but what I don't do is I do not replicate the database from the server to the client. In the case of a card game, and I've found in most web applications, you usually only want to show people in the browser what they're actually allowed to show. In the case of the card game, this is quite simple. You should not send out where every card is on the table, because then you could easily find out what your opponent holds, for instance. So Datomic, since I'm not going to deep dive into it, you'll just have to make do with these descriptions by me. Particularly the first one is important, that I consider it like a Clojure atom, but then as a database. And then if you're familiar with what CQRS is, I also use it often as a tool to just compare implementations. Because trade-off is, Datomic has a certain set of trade-offs it made, where certain things are possible in Datomic, which are maybe not possible in other systems. So I find it quite useful if you're making an event source system, or if you're using event source system with multiple event sources to think why is this not how Datomic works, and what do we lose when we do this? That's helpful if you know what CQRS means. What I do want to highlight in the architecture is that the communication between the client and the server is by sending data back and forth. And because this is Clojure, the data is maps and vectors of maps, just regular Clojure data. This is really nice. And one thing that sort of falls out of using Datomic is that this sort of becomes an event-based system. So on the client, people make actions. It's your turn to do something, so you drag a card, you select a card, maybe you discard a card. These all turn into events that go to the server. And the other way around, whatever happens gets broadcast from the server towards you, so you know how to update your display and see what the opponent did. This sort of looks like this. This is just to show that everything that goes back is just Clojure data. You can just, if you were to print what goes over the wire, this is it. But the important part is in the bottom half, where you see that each event also has a T associated with it, which is sort of like a point in time, a progression of states of the whole game as everybody makes a move. And this T is actually very valuable because this is a web application. You have a client and a server. So what can happen is that the connection disconnects. The user can always press F5, reload the page. Yeah, you just have to assume that at some point you have to set up the connection again. And having Datomic as a database, this is quite nice, because in Datomic you have both the full view of your database at a certain point in time, as well as you can track whatever happened between points in time. So in the normal operation mode, it's just events coming from the browser to the server sends events to the client. But if there is a reconnect, or the first time you load a page, or maybe you reload the page as the game is going on, we can use Datomic to get a view of the entire database, which in this case will be the entire table where every card is, and you can just send that over. So that sort of looks like this, where if you need to reset the entire table, you can just ask for the complete view at a point in time. So that's the one at T3. And then below, once you have the whole table again, you can again continue just to receive only the events that contain the updates. Yeah, so that's what I wanted to highlight about Datomic, that the power is really, I think, in having this T. So the power of T as a way of not just describing each point in time in your database, but also as a modeling tool in your architecture, because you have a reference to a consistent point in time for everything in your system. So this became the basis of designing the system. So if you have a disconnect, you need to know which T where you're at, from which T do you want to continue. And with the database providing this, you don't have to do this yourself by combining perhaps multiple sources of data or whatever. So maybe you've heard that Datomic is like a database that allows you to do time travel, which I guess is true. But this time travel is also useful if you only work forwards in time, because you still have the reference to each point in time. So like I said, it's really useful for handling reconnecting, but it's also useful for handling refreshes. So let's see if this works. So this part just basically looks nice, but this is one of those features that if you have to build it into a system at the end, then it can be quite hard. But with Datomic, because you have a consistent view, you can just render. It sort of looks like this, and it just looks nice because of the animation. So this is a web application in Clojure. At the time I built it with Ring and Liberator. I must say that since then I much prefer the pedestal web server. So I prefer to build Clojure applications on the server with pedestal. So two things that are useful from Clojure here. One is that the focus on data with Clojure is really helpful if you have a wire in between your client and your server. And that is true here too. And Datomic is indeed like Clojure's time model, but then for a database. Then we come to this year. This is 2017. The picture here is again in Amsterdam. This is a construction site for a new subway line. Of course, this subway line is years past due and way over budget. It's a bit similar to my card game. But I want to draw your attention to the yellow crane you see here. So often when there's a big construction going on, they don't just put a spade in the ground and start to work, but first they set up everything to make it a bit easier to work. This crane is an example of that, because that does the heavy lifting over time. I think, or at least I found with doing Clojure, that I try to do something similar. So whenever I have a project, I also build the tools beforehand to maybe work with the project a little bit easier. One of those things is to always set up a dev environment versus a production environment. So when you are developing the project, you'll likely want a REPL. Perhaps you want something that makes the code reloadable with components. But then in production, perhaps those things are different. You want different components. Maybe you lock down the REPL and other such things. I guess you have this with almost every programming language, but in Clojure this is quite important because of the dynamic trade-offs there are. But even nicer, I think, is to also build utilities that are more particular to the project you're doing. And I think Clojure really helps with this. You can do, you are designing something, you know which state you might want to represent, and you can also then make it just easier for yourself and just make tools to work with this state. This can be in a version of just visualizing what's going on in the system, as well as generating state data for tests or just trying stuff out. With this Gin Rummy game, I did this in the ClojureScript version, where at the bottom here you see a little table with the blue and green highlights. So this shows the 52 cards in a deck, and then the color shows where this card is, in your hand or in your opponent's hand, which card is the discard. And this gives a view into the state that helps while building it, so you can track where everything is. And I think this is easy to do because the core of your system is representing state, and then you can also make little tools to help you visualize the state. I think that's quite helpful. Also this year I had another interest in looking into all these AI things you might have heard of. So I thought there's this scheme opponent which has an AI, maybe I could beat it once and for all. So the idea first was to have to look into neural networks, and the first thing I did was to try and find if I could find a neural network that could distinguish between good hands, so winning Gin Rummy hands, and bad hands, hands that don't win. And to do this, I again had to build a utility. So I had to first get myself a collection of non-winning hands and winning hands. So using test check generators, I was able to generate winning hands. So if you have 10 cards, you need to make sure you have a set of 3, another set of 3, and a set of 4 cards that together form a winning hand. And with the test generators, this was possible. This is again an example of making a utility to create the data you need to build your system. And I think because in Clojure representing data is so straightforward, this also is pretty straightforward. So that was the first AI project I did, like, okay, can we distinguish good hands and bad hands, or can neural networks do this? Then I wanted to take it a little bit further, which is maybe we can build an AI that learns from self-play. This is something that is used in AlphaGo, and before that they had a project where the computer could play Atari video games, which it also learned either by self-play or with neural networks. And then the predecessor of that project is Backgammon AI in the 80s, which also learned by playing against itself, which is sort of the project that is a root for a lot of these AI successes these days. So inspired by that, I thought, okay, maybe I can apply that too. What would it be like to have this Gin Rummy game create an AI by learning from playing against itself? And the idea here is that it's a reinforcement learning, so because it plays against itself, somebody should win, and that can be a reinforcement signal to update your AI and then hopefully converge into a winning project. So what then sort of happens is you have a hand, 10 cards, you have a neural network evaluator that says, is this hand a good hand or a bad hand? And because you want to learn from self-play, in the beginning this is random, so the first hand evaluations have nothing to do with whether or not it's actually a good hand. And then it does self-play, so it has 10 cards. It can decide, okay, I get a card, which hand do I get then? How good is this hand? Should should I use this card or not? And then maybe it decides, okay, I won't do this. But then you get into a problem. Because this is self-play and the initial evaluation of hands is random. Then what this thing actually starts to do in the beginning is it gets like to the hand, it at that time thinks it's the best, but it isn't. It's not the hand that's going to win. Maybe it only has like 2 of the same and 1 straight flush in there, but it's never going to improve because at that time it thinks this is the best one, and it doesn't get to the signal of winning a hand where it can update the hand evaluations that it has. So what you then sort of get stuck in, so you write this program and then you have it running, but you see no progress because all it does is it has its hand, the 10 cards, it will take a card from the deck, but then immediately discard it. It will take a card from the discard pile and immediately discard it. So it won't actually try any new hands, so it will just get stuck on this local maximum. And then no learning actually takes place. So what I've learned so far in this project is that it is helpful to create yourself some utilities and build yourself some tools that make it easier during development. What I also learned is that sometimes if you try to learn something, you fail. Luckily, I think most of the time when you learn, you succeed. And I had a great time learning Clojure so far over these years. I've been lucky now to make a living using Clojure, so I look forward to learning more stuff with Clojure. Thank you. Yeah. Yeah, sure. Okay, so the question is, when moving from the scheme code to the Clojure code, could have used mechanical translation, or what steps, or what did I have to do? No, absolutely not. The biggest thing there is, like I showed this hand representation, so it's a factor of 10 maps with a card and a rank in it. But then also for this AI part, you also need to figure out, it's sort of like a search. I have 10 cards and I want to find out, is this a winning hand? So I need to find 3 different sets of combinations of cards. And for this, the data structure in the scheme version was a list. So this algorithm was always processing from the first to the last card, from left to right to the list, you might say. And then if you have Clojure data structures, you don't necessarily have a list. You can have sets of things, you can have a map. And then in this translation, if you try to decide, maybe I use a vector, but then I use a set to handle the cards I've already seen or something, and then you start to translate this algorithm, then at some point you find out, oh, they use the list, but not just because it's the only container they have, but also because they use the list and they needed to have like an index into the data structure. So you sort of, after a while, you figure out, okay, these are the things from the data structure they actually use. And then if you maybe use a map, whereas the index is also important, positional index is also important, then you're like, oh, maybe that was not a good idea. So I had more, I spent more time figuring out, okay, what's the proper Clojure representation from this everything is a list representation in Scheme, rather than doing this mechanically in some sort of Perl script translation way. That answers your question. So the question is, how do I choose the parameters for the neural network? These were random, I think. Sorry, I missed the last part. The biggest insight of how powerful this T was actually, of course, later after I also used, I built event sourcing systems in work too, where you have a lot of events coming in and then you need a consistent view of a database built from multiple event sources. And because Datomic has has this T reference, so you can always reference a particular point in time. That sort of influenced how I built it, because at the time I didn't know that how important this could be, but because I knew that Datomic had that became sort of the way I structured the architecture of this application. So the insight came after the fact. All right, no more questions. Thank you. Yeah, sure, overtime. Well, the origin of using DataScript there was because I saw the similarity, like, okay, Datomic and then DataScript in front end. So this fueled more.